As long as you keep it for your private records. I mean, I want nothing to be put on YouTube where I'm eating.
No, I just
like YouTube exactly where this is going.
Yeah, no, but it's okay.
Good. What are you eating, by the way?
Lentil and rice thingies.
Lentils. Okay, nice. That's perfect for when you're like really hungry and want 2,000 or something.
Yeah, exactly.
Perfect. Okay, let me. I'm gonna get an overleaf thing. What is the website called? Actually, it's not Overleaf.
Yeah, I think we used Overleaf.
Oh, it is Overleaf. Okay.
Also been using Chloe. Have you guys used that?
I tried using it for maybe half a day.
Mm-hmm. There's a plugin for it so that you can write LaTeX in it.
Cool.
Which is nice. I mean, I'm not really sure about how I should organize my different items into subcategories. And I guess I should be using hashtags more so that I have more of an interconnected mesh. But it's nice to have things organized in some fashion. I'm generally pretty bad at that. Wow, this is my paper, written by me and my abstract.
Where's the beginning document? Oh, here. Oh, I see. Okay, anyway, I'm sorry for this horrible document. Do I just like get rid of all this font encoding and crap?
Oh, wow. No, you don't do that.
Okay, it's back. Okay, you guys take over.
Okay, I'll put my preamble in. It's pretty long.
Actually, let me start sharing my screen just so that people can read your preamble.
Sure. Dun, 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 dun.
Perfect. Okay, cool. So, what a good transition to beginning talking about game theory. So where is everyone at right now in the textbook?
It's actually been a while since I looked at it. But yeah, I've done all the, or maybe not all, but most of the exercises for the first chapter, and I like skimmed the whole second chapter, but I don't think I read anything of like any part of it in detail.
You just did the exercises?
No, I didn't do the exercise either.
Oh, of chapter 2.
Yeah.
Oh wow.
So maybe a few of them. I could check. I have.
Okay, cool. So why don't we do?
Okay.
Oh,
do you want to hear my answer to the question as well?
No, I skip that.
No, but I've been blazing through chapter 1 today, and it seemed fairly straightforward. A lot of things that we had done before. I like the new focus on like actually computing the values of matrices and so on.
Yeah,
and then I just started reading how you do that more generally in chapter 2 for invertible matrices.
Cool. Yeah, chapter two is interesting. I really like chapter two. So I actually made it through a lot of chapter two, like read through it, kind of skimmed it, and then did like one or two exercises, borrowing a lot from the solutions manual. But you know, it's pretty nice. So why don't we go over like stuff in chapter one, the key concepts of chapter one, and you know, maybe end a couple exercises. Does that sound good?
Yeah,
Cool.
we can do that.
So first, Martin, how comfortable are you with the saddle point stuff? That's what we did last time.
Comfortable.
Okay, cool.
Yeah, so I mean, I did just a few. So sorry about this. My preamble is screwing things up for some reason. I'll just remove some of the packages, I think. But yeah, I've done a couple exercises just to check my sanity, and it turns out that I'm pretty sane because I was able to solve them. And it seems fairly straightforward. I mean, generally, given any matrix, you first figure out whether it has a max in the minimal value of the matrix and the maximum value of the matrix, and if they're different, then you can just make a system of linear equations, and then you solve it, and then you get your mixed strategies, your best responses.
Cool. I think that's a good high level. Do we want to skip? The first thing that I have circled that is not something we covered in the last session was problem 1.25.
I think I did that one. Yeah, I've done that one, exactly that one.
Cool. Maybe I'll open that up. Oh, you had a really, Jack, you had a really good like split screen view last time.
Yeah,
do you want to do that again?
absolutely.
So I'm actually going to stop share for now.
All right, so I screwed up the preamble. I don't know why it's different here than on my local LaTeX build, but it doesn't matter. We can just use something the way it was before.
Okay, there we go. This is good. So we want to do. Oh, solve the game graphically. Oh, yeah.
Which page of the book are we in? Is the problem?
1.25. Oh, page. It is page in the book 43, in the PDF 63. Cool.
Oh yeah, I did that one as well.
Yeah, it's a pretty good one.
Yeah, so we got that matrix A, right?
Yep.
And Jack runs away, but that's okay. So looking at the matrix B, we see that the second column has been removed and the first row has been removed, right?
Yes. And why is this?
This is because the second column is inferior as a strategy for player 2 than a convex combination of columns 1 and 3. In other words, we can assign strategies. We can assign probabilities to columns 1 and 3 so that those probabilities are better than ever choosing column 2 with any probability.
Yeah, and we have the kind of even though of course this seems like it's a really good choice, we by convention are assuming that the player 1 is the score is the score for player 1, and that player 2 the score is the opposite, because this is a zero sum game. Is that right?
Yeah.
Cool.
Yeah, and more generally, it can be a constant sum game. So we don't require player 2's payout to be exactly minus player 1's payout, but it can be a constant minus player 1's payout.
Yes, exactly. That makes sense.
But the same phenomenon applies, because to optimize an optimal strategy for player 2 is one that minimizes the payoff of player 1.
Yeah.
And so as player 2, we want to assign probabilities to the columns so that we get as low of a value as possible. And so if we only consider the first row, we can find a lambda such that the other two columns are better off for us to choose than the second one. Let me choose the equations down, and then I'll say why this is what we're gonna do. So this is what they're talking about in just the section before this exercise is given as a convex combination of the other two rows.
Yes.
So.
And what you wrote is a formulation of that, right?
Isn't a convex combination of the other two columns?
Yeah, of the other two columns. That's right. Yeah, so we want to show that there exists such a lambda which is between 0 and 1, including 0 and 1, such that these three equations hold, or inequalities hold. And so if we are able to find such a lambda, we don't need to worry about column 2 as player 2, because we can always be better off choosing one of the other ones. So simplifying this yields following inequalities. Hang on. Yep. Okay. I'm in the call. You're in the call. Yeah. Oh, never mind. Okay, later. See you. So this is what it reduces to. Is that clear to everyone?
Yep.
Yeah.
Cool. And so turns out that when we keep simplifying this, we get the following three conditions. The first is that lambda should be smaller than or equal to 21 fifths, but that is always going to be the case, so it really doesn't give us much information because never mind. I mean, that's
larger than 1.
Sorry?
That's larger than 1.
Yeah, exactly. Exactly. And the second one will give us that lambda should be greater than 9/13ths. Because if we multiply an inequality by a negative number, we flip it. And the third one gives us this. And where's the error? I need to end the split thing. Okay, good. That should do it. And now the only question then becomes whether we can find a lambda which is between 9/13ths and 3/4. And that turns out to be possible because 9/13ths is strictly smaller than 3/4, and an easy way to see that is just by realizing that 3/4 is 9/12ths, and 9/13ths is smaller than 9/12ths, and so there are values in between.
Awesome.
So that means that we can completely destroy or remove the second column, and we are left with a modification of A, which looks like this. Okay, we remove that thing, and that thing, and that thing, and we call it A prime. And now we see pretty easily that if we are player 1, then there would never be a good reason for us to choose row 1 over row 2, because whatever player 2 does, we're going to have better payoff with row 2 instead of row 1. And so we just remove the first row, and then we get the matrix B.
Yep. Nice.
Yeah.
That was very useful. I personally did not do such a comprehensive proof, which is this. So this was very helpful.
Yeah,
Did
and
you
then
still manage to solve it?
Would say that again?
Did you still manage to solve it? Because I would be interested in seeing your approach.
I basically just I was able to solve it, but I basically just did not explain as well why it can be reduced to b equals 18. You know, I didn't. Okay. I basically didn't give a good intermediary step for removing the second column.
Right.
I didn't do the thorough thing because I was just like, oh, that kind of makes sense, and threw it together.
Right.
Yeah, and then I'm not a huge fan of this graphical method because I find it, I mean, drawing these graphs is kind of nice, but if you want to find your optimal strategy, you need to solve it algebraically anyway.
Yeah. But the graphical method can be useful when you have more than three lines, because then you can use the graphical method to easily see which one of the points, like which one of the intersection points that you actually want to solve for.
Because you can see that some of them are useless, or
rather that one of them is going to be the highest or the lowest one, depending on which direction you're solving for. Like you can do that algebraically as well, but it's more work, seems like.
I think that,
but I agree that with two lines, there's no point. You just set them equal to each other and solve.
Yeah.
I think the graphical solution was useful for like maybe intuition additionally.
Yeah,
definitely. But anyway, if you want to solve this game, you look at these two equations and you put those equal to each other. Because at the point where they are equal, you will have reached the value of the game.
So, if you mind, let me ask a question. This is something that I think I kind of ran past. The so the equation that you know, the e x comma 1 whatever.
Yeah.
Let me notate. So that equation, where is that in the textbook? And what is it? What does it stand for? Because this is a core thing that I was confused.
Expected value of playing strategy X when the other player is playing strategy 1.
Okay, perfect.
Yeah, exactly. And so what it ends up being is just that you take the matrix. It's going to be X in our case, and you multiply it with, or sorry, the name of the matrix is B, of course.
You say the two options you have when the player 2 is playing 1 is 18 and 23, and so X is the probability that you play 18, and of course 1 minus X is probability for 23. You do that for the second column as well. and you then set them equal, and that's how you would solve it graphically in the first place.
So they will be equal at the intersection point,
Yeah.
and that's how you get the value for x.
Yeah, exactly.
Yeah, exactly.
Where did the math go? Where is it
On the second
recompiling?
page.
Ah,
Yeah, so this is, I don't know if it became less clear with me writing out explicitly what x1, the expected value of x1 is. But basically you just multiply it as you always do when you want to calculate the expected value with, so I mean generally, let me maybe write out generally e of x and y with in a game with matrix A is going to be that matrix. So the vector x multiplied with the matrix x multiplied with the transposed vector of y. And if you just put a scalar or just a number in one of the entries to the expected value, we understand that as that the player has chosen a pure strategy. So the vector is just 0, 0, 0, 0, and 1 at position I, and then zeros everywhere else.
awesome. Cool. So are we good for that that question?
I think so.
Here's the next question that I had kind of highlighted. Well, actually, first let me ask anyone any other questions from like either this section or previously?
Not really.
No, I thought it was cool. I never knew the games of the rules of Russian roulette in this detail.
Yeah, it's so cool.
Which rules? Sorry.
The rules of Russian roulette when they.
Oh, right. Yeah. I like that too.
Yeah. I never knew that there was a way to win without shooting yourself in the head.
Right.
Well, I mean, you're not winning that much. And also, it was funny that they placed no value on surviving.
I know.
Yeah. Yeah.
That's awesome. So maybe we can do question 2.1. If Martin, you haven't checked out chapter 2, right?
That's right. But I'm up for doing that.
Cool. Because 2.1 is pretty simple, and it basically uses those. Oh, does it already tell the equations you're supposed to use?
No.
Why? V of A, right? It says the matrix formulas can be simplified to where A. Oh, that's 2.4. Sorry.
Yeah.
It just so happens that they have written a lot of them down.
Yeah.
Cool. So 2.1. I think that's a nice one. Should I lead this?
Sure.
Okay. I'm not going to type the LaTeX as well as you. That was awesome.
Thank you.
Oh boy. Okay, and 2.1. Okay. So the equations that we will use are actually, are those the exact, Jack? Are those? Is there anything wrong with those equations, or can I just use them as reference?
Yeah, there's something wrong with them because maybe not, but that depends on whether the matrix has an inverse or not. Because otherwise, we're supposed to use the determinant and like A star instead of A inverse.
Yeah. So maybe we should just first check if there's an inverse, right?
Yeah, but there is.
There is. Okay. So then, well, damn, this is so hard. If anyone feel free to write with me. So A is equal to defense eight and 0. Okay, and then so we have A equals 1, 8, 10, 0. And that was given in the question. And we also have A inverse. Does this work? I don't think so. Does this work? The inverse of that. So given in the section, to get the inverse, we just flip the A1, 1 with A2, 2. So basically the first element top left with the bottom right. And then we negate the bottom left and the top right. Whoops. Okay. So is that showing up okay?
We were also supposed to multiply with or divide element-wise with the determinant, right?
Yeah.
We're supposed to divide by the determinant, you said?
Yeah. Yeah.
So this is what you will get because the determinant is A11 times A22
minus
plus,
80.
Yeah. Plus negative or minus A12 times A21.
Will that help? Wait, why? What is this?
Oops. I think we're all kind of editing the same block of code right now.
Yeah, sorry about that. Okay, I'm just gonna stop doing what I was doing. Fuck. Sorry. What is the error? Oh, I see. So there is an equation which they give where we find V, which is the value. And is that the expected, like what is the V? Because I actually kind of took it at face value and I think I knew it at one point. I know it stands for value, but what is the actual meaning of the value? Finding
of the game.
Value of the game, yeah.
It's like if all players play optimally, then, or I guess it's two players. But if both players play optimally, then
It's
player one will get the expected
value.
payoff for player one. Yeah.
Yeah, so it's expected payoff. That's kind of what I figured for player one if they both play optimally. Yeah. Okay, cool. So the equation that we use to find the optimal strategies or mixed mixed strategy weights, whatever they're called, is first you find the expected value, and then, or no, you don't even have to. Damn, I need to have written my work down here. Do you want to scroll up to where the stuff is laid out? I can find
Sure.
the spot, so I don't have to, because it's not clearly written in my notes. Here.
Talking about this.
Yes.
Because
yes.
we went with the other route now, I think, where we don't use A star, but the A inverse instead.
Oh, I see.
Using the formulas that were defined here in the exercises, because we knew that the game had an inverse, or the matrix of the game had an inverse.
I see.
So if we want to get the value of A, we can just use this formula on A.
I see. Okay, so that's why I was getting so confused, because I had used the other thing originally.
Yeah, me too. That's what's in my notes.
Cool. So A inverse is that. Now we can plug it in, and I actually had to look up a lot of matrix operations. I confess, I was not didn't immediately jump out, but I eventually got it.
Yeah, it was the same here. It's been a while for me.
Yeah. But really, all you're really doing from there on, now that we have the inverse, is plugging it into these equations.
Yeah.
And so, I mean,
we could skip a few steps.
Yeah, we could skip a few steps.
Yeah, because I mean, when you multiply the vector 1, 1 with the inverse of A and then with the column 1, 1, you're just gonna end up summing all of the entries in the matrix.
Yeah.
Yep.
So that would be negative 17 over 80, right?
Yeah.
I got 80 over 17, or like negative 80 over negative 17, but both.
Yeah, so the value is that.
Yeah. But maybe I did something wrong. Like, it's hard to check, given that I didn't write anything out.
Wait, did you get 80 divided by 17?
Yeah. I think I even checked it by inputting stuff, and
I mean, it's worrying if we get a negative number there.
Yeah, 80 over 17, I think is right. Is definitely right for the value, in fact.
Okay, cool.
But it doesn't make sense with respect to the equation that we're using.
In what way? What part of it?
I mean, when we do the multiplication, 1, 1 times A inverse times 1, 1.
This?
Yeah, exactly. I mean, that's just gonna give us the sum of all of the entries in the matrix. And so I don't see why we would end up with a positive number.
I think that the negative somehow I got super confused by that while I was doing the normal formulation.
Mhm.
And it seemed to work out. Maybe our is this right? This one, that one.
Oh, now I know what the problem is. So the determinant is going to be minus 80.
That's it.
Oh yeah, yeah.
Oh, I didn't even see. Yeah.
So this will be positive, this will be positive, and this will be negative. Cool. Yeah, awesome. Then everything checks out.
Cool. Yeah, so value is 80 over 17. And then we could technically write out, we could write out the other stuff, but it's basically, I can give you the answers.
Yeah, so the optimal strategy for X will be 11. Okay, nice.
Yeah, and I like this formulation because it's just using all the matrices. It helps my both review of like linear algebra and just comes out with, yeah, it's very clear. I've seen online formulations of this that simplify the way that you write it, and kind of say, do this for finding the first element or the first probability of X, and this for the second. But this, you just are using matrix multiplication, and you get both pop out immediately instead of like breaking it into their component parts, which I think is nice.
Yeah, definitely.
Cool.
Jack, did you say that you had done more exercises on other sections of chapter 2?
No, I looked over a few, but I haven't actually done them and written them. This is the only one that I actually did.
Okay. Cool.
But it was like 2 weeks ago since I did this. I have been looking at the game theory for a while, since we hadn't kept up with where I was.
Yeah.
I circled 2.21, which is essentially the same but different numbers, I believe. I wrote down, or maybe it was the same steps that were presented I wrote down follow same steps, but that might have been same steps in the section. I'm not 100% sure.
Did you say 2.21?
Yeah, 2.21.
Right, so this one.
Yeah, can be considered, yeah, so just like solve the game. It must be in the section, the steps presented in the section.
Cool, but since I haven't read section 2, does anybody want to tell me how to generalize the formula for n times n matrices, or n times m matrices?
I don't remember off the top of my head. Do you, Carl?
I not 100%. Here we go. This is what we. I believe we use theorem.
221.
Yeah. Oh, actually, let's do. Sorry, I skipped one of the questions. That's why it was same steps as 2.11. So 2.11 is a simpler version, I think. Do you mind if we do that one first? Because I have it written out. Sure. So for 2.11 for A, first what we do is we want to check to see that because we're doing 3 by 3, it's the way that we're going to solve it. It requires for it to be for there not to be a saddle point. And that's because if there is a saddle point, then we kind of just have a pure strategy. We need a mixed strategy. So if you look at A, you'll find that there's a saddle point at
a pure saddle point.
Pure saddle point.
Yeah. Okay.
Yeah. Sorry. Pure saddle point. You'll find that there's a pure saddle point at row 1, column 2. And I mean, we can always do that by at least so I think what we do is we minimize we want to find the minimum here. I'm always bad at finding saddle points, which is weird. That right there, and then 2 for this one. This is the maximum now, right? And then so we want to and that's 4. Sorry. And so now we want to maximize this, right? Because our equation for that's V. I think that's V minus.
Yeah.
And then this is V plus. And so we want to maximize this. So we see it's 2. We want to minimize this. We also see it's 2. And so they're equal and right here. So it's a pure strategy.
Yeah.
So that's A. A is pretty simple. And now there's B. So B is where we actually follow the steps. So there's theorem 2.2.1.
Bring that up.
Yeah, it's on page 66. Yeah.
So that's essentially what we did with V and X and Y in the previous exercise.
Yes, I believe that's right. It just basically says that there are a couple conditions. First, it needs an inverse. Then second, the Jn is a vector of just ones of length n, and a inverse, and then J transform n, which is like a column instead of a row. Is not equal to 0. So what that means, am I correct? So I actually wasn't sure about this, but now that from what you said, does that just mean that all of the elements inside of the inverse of A have to add up to, not add up to 0? Is that right? For this.
In the inverse of A, yeah.
Yeah, in the inverse of A.
Yeah. Yeah, I think so.
Okay, cool. And we also have to, this thing, I actually don't know the intuition behind these two parts of the theorem. And then we do exactly what we did before, right? I believe.
I mean, the second part is just, we can see that we're going to divide by 0 in this formulae, otherwise.
That makes sense.
Yeah, exactly.
And if it doesn't have an inverse, that means that the determinant is 0, and then the value of the game is 0 anyway. And I'm not sure why they're like considering that to be an uninteresting game. Or
no, they talk about that in other some other place, and so I remember at least one suggestion is to just add a constant to all outcomes, and then most of the times, or at least some, I'm not sure if it's all the time, but many times you get an invertible matrix, and then you can solve for that, and because it's just a scaling of the previous game, you get the same strategies. but I am not sure if that covers all cases, and I think they might have talked about the rest, but I don't remember.
Yeah. I mean, there would definitely be cases where scaling doesn't really help, or adding a constant wouldn't really help. But I'm not sure the exact conditions. Maybe that the matrix would be symmetrical.
Oh, but wait, that's what we had. Like, here. So A star is just the inverse of A, but without dividing by the determinant.
Right.
So these are the general ones, but these can be simplified to use the inverse of A instead. In the case where you have an inverse.
Yeah, that's a good point.
Oh, so you can't. So the determinant can't be 0, of course, because.
Yeah, if the determinant is 0, then the inverse doesn't exist.
Yeah.
Yeah, but A star always will.
Yeah, exactly.
Yeah.
So really, it seems like the second condition is the most important one then, because I think that if the values of the exactly. So if Jn A inverse Jn transposed is 0, then Jn A star Jn transposed would also be 0, because the only difference between the two is by a scalar, right? It's just dividing by the determinant. So we would run into troubles there also. But I think, wasn't it the case that when Jn A star Jn was 0, that we had a pure strategy? Or something like that?
Sorry, could you repeat that?
That when the sum of all of the entries in the matrix, when the sum of all of the entries in A star was 0, then there was a pure strategy in the game.
I don't recognize that, but you might be right.
I mean, that would make sense, right? That would fit in very nicely.
So, yeah, I mean, it's in remark 1, just in the beginning of the chapter.
In chapter 2?
Yeah. They say that it's not difficult to check that when A11 minus A12 minus A21 plus A22 equals 0, that the V minus and V plus are equal. And so there is a pure strategy.
Cool.
And so I think that this generalizes into n times m matrices as well. Right?
Probably.
I mean, that would be a good exercise to prove that. But I don't think that it's something we should do on the fly. But it's left as an exercise to the viewers of this video. Cool. Yeah.
Awesome. So as a little piece of meta, hopefully this doesn't distract us. I've considered, I haven't yet done this, but I'm curious. I'm thinking it would be nice for our viewers if we have a little bit of an intro to the video. And so I wanted to, my thought for the intro was start every video by screen sharing a recording of the last video, so that we can eventually, like after like 4 times, have like this nice, recursive, 4 deep video of a video of a video of a video. And just like always start out by adding one to the chain.
So would each video become like 1.5 hour longer than the last week's?
No, I'm just thinking for a certain 20-second period,
All right. Okay.
5-10 seconds. Anyway, may do that. I've been every like few days, I just fantasize about doing that, but I never start it because I'm like, oh, it's going to be so long, to 3 weeks for it to be a depth of 3.
Yeah, but I think we can start by displaying the segment of you explaining the idea. I mean, that should be what we're
Yes, that's genius. Okay, I'll
Nice.
make sure to clip that out. Cool. Sounds good. So I'm thinking we're about at an hour. For next week, do we want to just finish up chapter 2 and then like we can play with chapter 3 a little bit? Like I personally, I'm most of the way through chapter 2 in my like surface level overview. Does that make sense?
Yeah, I think that makes sense.
I'm interested in blazing through this textbook because I really want to be like, I want to get up to coalitions and like really cool stuff that I've heard about.
Yeah.
So.
Yeah, I mean, this textbook is very wordy, I think, which is not something bad, but it's very American in the sense that, American textbook authors get paid by the word or the page count, it seems.
Yeah, I mean, I don't know about that, but I do know that this is a wordy textbook.
I mean, I do know that is the case for some textbooks, and I don't know if this was the case for this, but it's the feeling that I'm getting.
Wow, that's crazy. That's like paid for line of code.
Yeah.
Yeah.
Interesting. Wow. Well, I think that makes sense. I think that this textbook, even if it is wordy, it is definitely better than the previous one.
Oh, definitely.
Just like a million times better.
Yeah.
I agree. No, there's nothing negative about it being wordy.
I think there's some little negative component to that, but mostly I'm happy with this book.
Yeah, totally. Cool. Sounds good.
So chapter 2 for next week, and if people have the time, they are of course free to check chapter 3 as well. Was that the conclusion?
Yep, that sounds good. I'm probably going to revisit chapter 2, and then because I've already kind of gone through it, go to chapter 3 a little bit.
Yeah.
Nice. Cool.
Awesome.
See you
Right.
Or
right.
Tuesday, maybe.
See ya.
Yeah.
Yeah.
Bye.
Bye.